All right, let's try this again. Whoop. Stay. This is so hard. They did not teach me this in grad school. Is it good?
Yeah.
Okay, you guys keep an eye on it. All right, so right here, where the motor neuron is going to reach the muscle, which is the what type of cell? Effector cell. Okay, we've got a synapse, and it's going to synapse with as many axon terminals as it wants to, as many as it's touching. So let's zoom in. Now you need to draw. I don't like this marker. I need a cheat sheet so I don't know how I drew it. Where did I set my cheat sheet? All right. So our axon terminal kind of looks like a fist, if you remember. So axon terminal is going to come down and look like a fist. Can you see that on the video? Can you see that picture? Yes,
a little bit.
just not great.
No, it's not,
all right.
It's not great.
And here is the surface of our muscle. Okay, I drew it red because it's a muscle.
You need to draw this, right?
Yes, draw this.
How big should it be?
I drew two. So we're gonna draw. I drew this one down here in the corner, and then we're gonna draw one across the top, and then over here
So
we
it
save
should
it
be
for the
small.
steps. Okay. So we're gonna draw a close up of what's happening in the sarcomere at the top. We're just not gonna draw that yet. I drew this in the bottom corner,
Can I
and then
see
our
how
steps
big
will go
that
over
is?
here. You can put it however you want. You have two sides of a piece of paper.
But mine has Sharpie.
Well, unfortunately for you, or I mean, fortunately for you, I have more paper up there if you need it.
Okay.
And I have already scanned this, and it will be on my blog. So I want you to draw it so you get practice, because I think you learn it better when you do it. But if you want to use mine, you can too.
So this goes in this spot.
Bottom left. All right. Who's that? Hi, sir. Oh, good. Do it. All right. So, where is the nerve impulse coming from? From the nerve, right? Okay, so from the axon that's up here. So this nerve impulse is coming in here. Impulses only go one way, right? We have depolarized this last little node of brain VA. Okay? Here's our last node. What's coming in to depolarize this last node? Depolarization happens from what?
Sodium.
Sodium first. So sodium is coming in. Instead of being followed by what? What would normally happen? Potassium would come in and repolarize. What happens instead after the last node?
Calcium.
Calcium. So calcium's going to jump on the train. Calcium gate opens. Okay, calcium floods in. I put calcium as little triangles, little teepees. Maybe because I'm from Oklahoma. All right, what's calcium's job?
Yeah.
Somebody said it. What does calcium do?
Pushes the vesicle.
Pushes the vesicle. What type of vesicle is this? Synaptic vesicle. So we've got these big vesicles. Now it looks like a nose. That's all right. All right, so we've got synaptic vesicles. What are they going to attach to on the membrane? Snare proteins. There they are. Nose hairs. Now it looks like we got boogers. All right. What's inside these synaptic vesicles? Neurotransmitters. So we've got neurotransmitter in here. That looks like boogers. Wow, we're really just rocking and rolling here. All right, so neurotransmitter. What's going to happen to these snare proteins, like Hulk Hogan?
It's going to rip open.
They're going to rip open. Some poor soul is going to watch these videos thinking that they're really educational and they're going to get things like Hulk Hogan actions from me. It's going to be great. So what's going to happen to these neurotransmitters? Is there any neurotransmitters down here?
No.
No, so what have we created? Big long word.
Concentration.
A big concentration gradient. So it's going to move from what to what? High to low. So these neurotransmitters are going to come out, and what do we call this? Going from high to low? Not osmosis, but diffusion. They're going to diffuse across the synapse. And they're going to hit the muscle. Okay? In this sarcomere, and this is one sarcomere. Okay. this would continue. Remember, this is one big long burrito. Okay, so we got another sarcomere here and another sarcomere there. Do muscles ever, in action, lengthen?
No.
No, muscles are rubber bands, or not like rubber bands. They're the opposite. They only shorten. Muscles only shorten. So how does the muscle shorten? Well, it's going to take this sarcomere and squish it like this, and then when it relaxes, it's going to go back to its normal state. Now, you can stretch a muscle, okay, but the muscle is not in active contraction when you're stretching. Okay? Now, if I pick up a ton of bricks, can I hold it forever? What's going to eventually happen? I'm going to get tired, and my muscles are still contracting, attempting to shorten, but they're going to be lengthening because those bricks are getting too long. That's a special type of contraction called eccentric contraction. That builds the most power. So, Braxton, when you're trying to lift weights and get buff, eccentric contraction is actually the best. Okay, so things like box jumps, where you have to load and fire those hamstrings when you're landing, but they're actually lengthening as you land. That's the most powerful. Okay? What type of contraction is this? Is my muscle shortening?
No.
No. This is called concentric. Not doing anything. Or sorry, isometric, excuse me. Iso means same. Okay, so stay the same length. Concentric would be 2004, 2005. Okay, push-ups are going to be both con and eccentric. Because when you're going down, what muscles are shortening?
The back muscles.
Your back muscles. What muscles are lengthening when you go down?
Chest and triceps.
Your chest and your arms. Okay? So when you push up, what's shortening now? Chest and your arms. What's lengthening?
Back.
Your back. Okay, so they're actually kind of partners. When you do a bicep curl, what's shortening? Biceps. What's lengthening?
Tricep.
The opposite side. It's an antagonist-protagonist relationship
It's
every
always the
time.
opposite side.
It's always the opposite side.
Oh, so like your back and
Yep. When you do abs,
Your back.
length, shorten. Okay, when you get on that little ab, the mermaid thing, your back is shortening, your abs are lengthening.
So what actually like makes your muscles bigger?
So what makes them bigger?
Yeah, like
When you work out, you create all these little micro tears in your muscles, tiny, tiny little tears, and your body puts fluid there, and it starts to lay down calcium to try and rebuild it, and that's why they get a little bit bigger. That's why it's not good to go do 1,000 bicep curls, and then the next day do 1,000 more, and then the next day do 1,000 more.
Don't coach bleeding though.
Well, yeah, that's why I don't coach football. It's better to do biceps, legs, back, then 3 days later come back and do biceps again when you've healed the damage that you did the first time.
aren't you all doing
So is it really-
Fridays now?
So what?
Yeah,
Does it make you
we're doing
stronger?
freaking yoga.
To do it day after day?
Yoga's where it's
You'll
at.
get stronger, yes, you'll get stronger if you do smaller numbers with increased weight as you go. If you always go in and do 15-pound bicep curls, you're not going to get that much stronger over 6 months if you continue to do 15-pound bicep curls. But if you go until you fail, you say, okay, I'm going to do 15 bicep curls until I fail, and I got 30 today. The next time you do it, 3 days later, you should get to 35. And the next time, you should get to 42. Okay, so that's the strength. But it would be better if you just went up to 20 the next time. Okay, so if you want to learn to do push-ups, do push-ups until you can't do them anymore. Then the next day, do push-ups until you can't do them anymore. Okay, and eventually you'll see they get easier. It's shocking. Lots of that is just your muscles figuring out how to work together, but then eventually you start to see actual strength. All right, so we're back to our neurotransmitters and diffusion. In your muscles, you have, is this a cell? Are muscle cells? Cells?
Yes.
Yes, okay. What do you find inside cells? Think about my little posters on the back. Organelles. Does every cell in your body have organelles? Yes. Okay. So they're going to be called a little bit different stuff, but they're all the same. Okay. So in our muscle cells, the first big highway we have is going to run right down the middle of a sarcomere, and this is called a T-tubule. All right, so this T-tubule is going to run kind of all web-like over our myofibril, our little muscle cell. And each sarcomere is going to have access to a T-tubule. This T-tubule is like the sewer system. Okay? It's tubes that run through and around but aren't actually embedded in the sarcomere. They're kind of on top or underneath. All right, so the T-tubule is going to pick up these neurotransmitters. And these neurotransmitters, where'd my lime green go? Are going to roll through this T-tubule, kind of sending this impulse down the muscle fiber. Okay, so we're going down. Now, the action of that neurotransmitter. The neurotransmitter is kind of like a ligand, right? What's a ligand? A signal, okay? So when this signal travels through this sarcomere, it touches the sarcomere, we have our internal cell organelle highway. What is our cell organelle highway? What is the place that causes the chemical reactions and transports things around? ER. Okay, not quite cytoplasm. Cytoplasm is there to keep everything afloat. Right? If we didn't have cytoplasm, everything would fall to the bottom. So ER. We have a special kind of ER. It's called Sarcoplasmic Reticulum. Why do you think they call it that? Because it's in a sarcomere. Okay. So you have this, and this is just how I draw it. It's not actually what it looks like. This is your Sarcoplasmic Reticulum. It's actually folded, flattened sheets. You know that. All right. So we have this Sarcoplasmic Reticulum, and I'll write that name in there. And the Sarcoplasmic Reticulum is going to change that signal from a neurotransmitter to what? What do you think? Before, when we had neurotransmitters, what did we change it to? Potassium and sodium. What are those? Ions. What do you think we're going to change it to this time? Ions again, right? We always go from chemical to electrical, electrical to chemical. We're always flip-flopping, okay? Your ears went from stimulus to electric, right? We didn't have a chemical there, but we always are having to formulate that signal into something our cells can understand. So out here in our actual cell portion, I'm trying to figure out a good color for this. Brown is good. All right. We have thick filaments and thin filaments. So thin ones and thick ones, and thin ones and thick ones. Are you freaking kidding me? This is taking 3 days to try and get done. All right, so thick and thin. These thick filaments have what are called little heads on them. Little golf clubs. A little, almost like antenna. Okay? When that neurotransmitter comes through the T-tubule, it's going to signal the Sarcoplasmic Reticulum to release calcium. And calcium is going to start flooding out into this sarcomere. Okay? We will zoom in on our thick and thin filaments tomorrow. Because I'm a loser. I can't get it done in one day. Alright, but if you watched Big Guns, you have a clue about what's going to happen, right? We got to let the kids touch each other at the dance. Right? So, they're not touching yet, but they want to. So we got to find a way. Calcium does the job for us. Alright, hang on to this. We'll finish this tomorrow. I'm a loser. I'm sorry. I'm really disappointed in myself for not getting that done. You will not have a math quiz tomorrow. You will not have a regular quiz tomorrow.
We can continue calling things.
You will not have math. You will not have a content quiz. You will have a synthesis question. Okay? The second largest user of ATP in your body. How about locomotion?
Or drugs.
I don't know how many drugs you use, but...
That's on camera.
All right.
Okay, well, cut that.